All right, for the final question, question 7, we're going to be covering a couple of different pieces. It says, for each system below, complete the table with the information requested. It's given us 2 equations for each type. It wants us to graph, then write the number of solutions, write the relationship, asked us to solve it algebraically, asked us to write the equations in slope-intercept form. We even compare our slopes and y-intercepts and classify the system. So let's get started. We're going to look at these one at a time and not all 3 together. First thing I'm going to do is I'm going to graph these 2 equations in this first column. So I'm going to first work down this very first column on the left-hand side. And I'm going to start by graphing these in the Desmos. We've got 2x maybe. There we go. 2x plus y equals 2. So it looks like I have y-intercept at 2 and an x-intercept at 1. So I'm going to graph that. And then I'm going to plot that, and I'm going to connect those 2 dots with a line. As so. Okay. Next, I'm going to graph my next equation, which is 6x plus 3y equal to 6. And if you notice, I can turn the lines off and on, but I'm only getting one picture in the end. So I've got the same line. So the next piece tells me, write the number of solutions. Well, if I only have one line, how many solutions do we have? This is what we call infinitely, I-T-E-L-Y, many solutions. It says, write the relationship of the lines. So are these intersecting lines, coincident lines, or are these parallel lines? Coincident. All right. It says solve algebraically. I am going to solve this first equation for y. Off to the side here, I've got 2x plus y equals 2. I'm going to subtract 2x from both sides. Oops, x. That's going to give me y equals negative 2x plus 2. I'm going to solve the second equation for y as well. We've got 6x plus 3y equals 6. I'm going to subtract 6x. It gives me 3y equals negative 6x plus 6. And we can divide by 3. This gives me y equal to negative 2x plus 2. So now that I have both of these equations set equal to y, I can set them equal to each other. So I'm going to say negative 2x plus 2 equal to negative 2x plus 2. Add 2x to both sides. We have 2 equals 2. My x is canceled out on both sides, and this is a true statement. It asked us to write the equations in slope-intercept form, which is what I actually did over here off to the side. And that was y equals negative 2x plus 2 for both. Can't see what I wrote. Sorry. It says compare the slopes. My slopes were m equals negative 2, and my b's were 2. They were the same for both. It says classify the system. And that goes back to this part. Are we distinct or are we independent or dependent? Are we inconsistent or consistent? So we have one line, so that is a dependent. But we have infinitely many solutions, so that makes it consistent. Ooh, I need to go back and change number 6. The third one, that was independent, now that I'm looking back at it. So please make sure you go back and note that I changed that. It should be independent / consistent. All right, let's take a look at the second set of equations that they gave us. I'm going to start by plugging this into Desmos. The 2x plus y equals 2 is already my first equation. So I'm going to go ahead and cancel out the second one. And I'm going to graph it. It is x plus y equals 3. Ooh, okay. So my first line was this. Here was my first line. And my second line looks to be like this. So, if you notice, these two lines are intersecting. And we have one solution. If I want to, and I go back over to my picture over here, it's telling me that my solution's at negative 1, 4. So we should have a solution at negative 1, 4. We'll check that out here in just a second, right here where it asks us to solve this algebraically. I'm going to go ahead because I know here in just a second I'm going to have to write these in slope-intercept form. Well, we already know that the first one is this y equals negative 2x plus 2 because that was the same from previous. But let's find out what that second one was. It was x plus y equals 3. I'm going to subtract x from both sides. We get y equals negative x plus 3. So my second equation in slope-intercept form is y equals negative x plus 3. Because I have these set equal to y, I'm going to set them equal to each other. So negative 2x plus 2 equals negative x plus 3. We're going to subtract 2 from both sides. We get negative 2x equals negative x plus 1. I'm going to add x to both sides. I get negative x equals 1. Got to get rid of that negative in front of the x, so we divide by negative 1 and get x equals negative 1. So far, so good, because I said that the answer should be negative 1 comma. Now we're going to plug this into one of our equations. X plus y equals 3. Well, I know that x is negative 1. So negative 1 plus y equals 3. We would add 1, and y would equal 4. Earlier, I said my ordered pair when I graphed it was negative 1 comma 4. Same thing. What do I notice about my slopes? Slopes are different. Y-intercepts are different. Now it asks us to classify our lines. I got 2 distinct lines, so these are independent, and I have at least one solution, so it's going to be consistent. So we have independent and consistent. On to the last set. Well, that top equation has been the same for every single one of them. So I'm going to go ahead and graph that. Now we're going to graph this 4x plus 2y equals negative 4. So let's go ahead and graph that. 4x plus 2y equals negative 4. Looks like I have a x-intercept at negative 1 and a y-intercept at negative 2. X-intercept here, y-intercept here. And how many solutions do we have? None. Not going to intersect. What kind of lines are these? Remember that these are parallel. It asked us to solve these algebraically. I already know one of them because it's the same equation we've been using. So that's y equals negative 2x plus 2. But let's go ahead and solve that second one. That second equation was 4x plus 2y equals negative 4. We're going to subtract 4x. So I have 2y equals negative 4x minus 4. We're going to divide by 2. Y is going to equal negative 2x and minus 2. So y equals negative 2x minus 2. Set these equal to each other. Negative 2x plus 2 equals negative 2x minus 2. Well, we would add 2x to both sides. Our x's would cancel out, and I'm left with 2 equals negative 2. This is a false statement, which would lead to that no solution. Means no matter what number I plug in there, it's never going to work. What do we notice about our slopes? Slopes are the same. Y-intercepts are one's positive 2, the other one's negative 2. So they are different. Now it asks us to classify our system. Do I have two distinct lines? Yes, so that makes this independent. Do I have at least one solution? No, so that makes this inconsistent. On to the wrap-up of this lesson.